Hello everyone, I am Dr. Fawzul Atik. I am giving some series of lecture for the course Probability and Statistics, and we are in the topic of continuous type random variable. In the previous two lectures we have discussed about the probability density function, cumulative distribution function of the continuous random variable, then mean, variance, standard deviations, couple of examples we have solved, right? So in today's lecture we will introduce some special type of continuous random variable, right? So we'll start with the uniform random variable. What is that? We say that x is a uniform random variable on the interval alpha beta if the probability density function of x is given by that fa equal to 1 by beta minus alpha, where a value is whenever it is lies between alpha and beta and equal to 0 otherwise. So a random variable whose probability density function is this, you called it as a uniform random variable, right? Now it is a density function and you can easily verify that yes, it should be a density function. It is again a positive quantity because a values in lies between alpha and beta, so it will always gives you the positive value. And integration minus infinity to infinity fx dx is actually you should have 1. Let's see whether it is 1 or not. So minus infinity, it will be here, from here it is alpha to beta, and fx is what? 1 by beta minus alpha. So it's basically a constant value into dx. And if you do the integration, it will be beta minus alpha and x dx, x and x runs from alpha to beta. So this is actually beta minus alpha divided by beta minus alpha, therefore this value is 1. So it is easily we have verified, yes, it is a probability density function, right? So a continuous random variable whose probability density function is this, you call it as a uniform random variable. Now, once we discuss about a random variable and its probability density function, we should always think about its distribution, that cumulative distribution function, right? And we know that the definition of cumulative distribution function is what? That means your if a function is actually probability of x is less than or equal to a. And in case of a continuous random variable, this quantity p of x less or equal to a is basically you have to take not all possibilities, so minus infinity up to a and then fx dx. Fx is the probability density function. Now for this particular type random variable, uniform random variable, what is the probability density function? So we should check that where it has the value differ. So before alpha it is 0 and after beta it is 0. Between alpha to beta it has some particular value. So whenever you have your a quantity is less than alpha, if your a is less than alpha, then what will happen? Then your capital Fa is actually 0 because minus infinity to a fx value is 0. So therefore this value is actually 0. Whenever your a value is lies between from alpha onwards and up to b. So if you have alpha less or equal to a and less than beta. If you have this situation, what is your Fa? Your Fa is equal to this minus infinity to a fx dx. But here it will start from alpha only because alpha a value is between alpha to beta. So you have to take from alpha to alpha to a, and the fx value is 1 by beta minus alpha into dx. And if you choose do the integration, it will become a minus alpha divided by beta minus alpha. I hope it is clear. And if your a value is greater than or equal to beta, what will happen in this case? Yeah, we know from the definition also it will become the total probability, right? Because alpha value is greater or equal to beta. So, but let's see, it should be the total probability, and it will start from where? Anyway, minus infinity to a, but fx value is non-zero between alpha to beta, so you have to take alpha onwards. So alpha to a fx dx. And whenever you have this a value is after beta, so up to a alpha value, it is value 1 by beta minus 1, right? So basically, a value is greater than or equal to beta, so you have to take alpha to beta fx dx. And between this value is 1 by beta minus alpha, and x into beta minus alpha, therefore it is beta minus alpha, and this value is 1. Yes, that is expected. You have to, you will get this is 1, right? So therefore, we got the distribution function, cumulative distribution function. If you just do it, you have got it as this function. You have got it as this function. So if your a is less than alpha, it is 0. If your a is between alpha to beta, then a minus alpha by beta minus 1. And if your a is greater or equal to beta, it is 1. Right? And if here in these two picture we have plotted them. So if you plot this fa function, it is before alpha all the values are 0, and from alpha to beta onwards it is a straight line, basically an increasing function, so it will be like that, and after onwards it is 1. So not only here, it can move up to infinity, all the values is 1. So it is just a plot of this fa, and this is the plot for uh, the PDF, probability density function, because it is the value is 1 by beta minus alpha between alpha and all other places it is 0. It is 0. Clear? Okay. Now, as usual, once we have discussed about a new kind of continuous random variable, we have discussed its cumulative distribution function. Then the next is what is its expectation value and what is its variance. So we know that probability density function is what? So f of x is equal to 1 by beta minus alpha whenever alpha less than x less than beta and equal to 0 otherwise. This is the density function. So what is the expected value? Very easy. E of x is equal to, only it will be between alpha and beta because other places it is 0, into x into fx dx. Fx value is beta minus alpha and dx. So therefore 1 by beta minus alpha will be outside, and x dx is x square by 2, and limit is between alpha to beta. So therefore, which is beta square minus alpha square divided by 2 into beta minus alpha. And it will, if you simplify it, actually you will be getting beta plus alpha divided by 2. So what you understand that if we have a uniformly distributed random variable over the point interval alpha beta, the expected value is what? Beta plus alpha by 2. What is that? It is actually the midpoint of the interval alpha beta. Right? So the expected value is its midpoint of this interval. And now think about the variance. To calculate the variance, what we have to do? We first have to calculate the we have to calculate expectation of x square. So e of x square is what? Again, alpha to beta x square 1 by beta minus alpha dx. So again, you take it out, beta minus alpha. X square dx means x cubed by 3, and range is between alpha to beta. So this is beta cube minus alpha cube divided by 3 times beta minus alpha. So if you just put the formula for a cube minus b cube, it is beta minus alpha into beta square plus alpha beta plus alpha square. So beta minus alpha will be cancelled out. So it is beta square plus alpha beta plus alpha square divided by 3. So e of x square is this. And therefore, what is variance? So the variance of x is e of x square minus ex whole square. And therefore, if you just simplify these two values, beta square plus alpha square by 3 minus beta plus alpha by 2 whole square, if you simplify, finally you will be getting beta minus alpha whole square divided by 12. right? So for the case of a uniformly distributed random variable over the interval alpha beta, your expected value is alpha plus beta by 2, and its variance is beta minus alpha whole square divided by 12. So what is beta minus alpha? It is the length of the interval. So it is the square of the length of the interval divided by 12. Clear? So very easy and straightforward type calculation it is. Yes, that's what we did. This is the expectation and variance calculation. Okay, now let us do some couple of example which are very easy in nature. So x is uniformly distributed function over 0 to 10. We have to calculate some probability. So what is the PDF? Probability density function of this fx fx is equal to 1 by 10 minus 0, so 1 by 10. When 0 less than x less than 10 and equal to 0 otherwise. So this is the probability density function of this. Then the problems, the calculations are very easy. So what is the probability that x is less than 3? So p of x is less than 3 is what? It is the x value is up to 3, but it starts from 0. So it is 0 to 3 fx dx. Right? And 0 to 3 fx dx, the fx value is always 1 by 10. So it is 1 by 10. I'm taking it out. And 0 to 3 dx. So that means x over 0 to 3. So it is 3 by 10. What is done? The part B is when you have x is probability of x is greater than 6. So P of x greater than 6. What is this value? All it is value is from 6 to infinity, but fx value is non-zero between 0 to 10. So we can see directly see it is from 6 to 10 fx dx. And so 6 to 10, maybe I'll write down 1 by 10 dx, and therefore it is x by 10 between 6 to 10. And 6 to 10 means 10 minus 6, so 4 by 10, and therefore it is, if we just simplify, the value is 2 by 5. 4 by 10 means 2 by 5. The third part, it is between some interval 3 less than x less than 8. Very straightforward, very easy kind of calculation for this. It is between 3 to 8 fx dx. So again 1 by 10 will be out. X is the integration 3 to 8. So 8 minus 3, so 5 by 10. Therefore this value is 1 by 2. Done. Right? This problem is very easy. Okay. Now we will do another one. Yeah, this problem is already done. We have done in the last thing. Now we have this another example which is very interesting one. What is this? Buses arrive at a specified stop at 15 minutes interval starting at 7 a.m. That is, they arrive at one of the bus will come at 7, then next is 7:15, next is 7:30, 7:45, and so on. So in 15 minutes gap, one bus will come. And now if a passenger arrive at the stop at a time that is uniformly distributed between 7 and 7:30, find the probability that he waits for less than 5 minutes for a bus or more than 10 minutes for a bus. So here, what is the random variable here? It is the passenger at the arrives at the stop at a time which is uniformly distributed. So x is a uniform random variable between 7 to 7:30. That means x is a uniformly random variable between 0 to 30 minutes, right? So accordingly, we have to define what is x. So the solution for this question is that define an x. So take x is the variable which is the arrival time of the passenger in minutes after 7:30 p.m. So this part matters. What is your x? So let x be the arrival time of the passenger. Arrival time of the passenger of the passenger in minutes, because here the unit is minutes, after 7. So after 7 a.m., that whenever the passengers is coming, when x value can be 7, x value can be 7.71, 72, 73, it can goes up to 730, right? And it is given that x is uniformly distributed over 7 to 730. That means it is uniformly distributed over the interval 0 to 30, right? So depending on our choice, because we have taken x is the arrival time of the passenger between 7 to 730, right? So therefore x is a uniformly distributed random variable or uniform random variable over the interval 0 to 30. So what is the PDF of it? So probability density function of it is 1 by 30 minus 0. So this between 0 less than x less than 30 and equal to 0 otherwise. So this is the probability density function we got. Now the question is, what is the probability that the passenger have to wait less than 5 minutes for a bus? Now passenger have to wait less than 5 minutes for a bus means what? So the passenger will come between 7 to 7:30, and buses will come at 7, and it will go, next bus will come at 7:15, and it will go, and next bus will come at 7:30. So passenger have to wait less than 5 minutes means what? So then passenger has to come in which time? So if the passenger is coming between 7:10 to 7:15 minutes, then only this passenger have to wait for less than 5 minutes, right? Because at 7:15 there will be a bus. Or if the passenger will come at 7:25 around, so 7:25 to 7:30, if the passenger comes in this time also, then also the passenger have to wait for less than 5 minutes, because again at 7:30 there will be another bus, right? So therefore you have to calculate the probability of these two to get the probability of less than 5 minutes waiting time. And 7:10 to 7:15 is basically, for x it is 10 to 15 minutes, or for x it is 25 to 30 minutes. So you have to calculate the probability of that. So the answer for the first question is, the probability that he has to wait less than 5 minutes is basically probability of 10 less than x. Just a minute. Okay. So the probability of the first part is probability of 10 less than x less than 15 plus probability of next is 25 less than x. Yeah, 25 less than x less than 30. So these two. Now, what is this probability? We have already checked. Its probability density function was 1 by 30. So it is 10 to 15, 1 by 30 dx plus 25 to 30, 1 by 30 into dx. And if you do the calculation, and after simplification, let us see what value we'll be getting. So 1 by 30 will be outside, 15 minus 10. So therefore it is 5 plus 1 by 30 will be again outside, 30 minus 25, it is 5 again. So it is 1 by 6 plus 1 by 6. Therefore this value is actually 1 by 3. Clear? The next part. Now the passenger have to wait more than 10 minutes for the bus. What you have to do? So in this case, if the passenger come at around, what time it has to come? So more than 10 minutes. So if the passenger is coming between 7:05 to 7, right? If the passenger comes between 7 to 7:05, then definitely the passenger have to wait more than 10 minutes. Why? Because the first bus will go at 7 and the passenger is coming after 7 to 7:05. Next bus will come at 7:15. So if he comes within this time, he has to wait at least 10 minutes. Or if he comes at around 7:15 onwards, to what time? 7:20, up to 7:20. If he comes up to this time, then also he or she has to wait, the passenger has to wait more than 10 minutes. Why? Because the next bus will come at 7:30. Right? So for X, these two values are from 0 to 5 minutes or from 15 minutes to 20 minutes. So to get the probability that the passenger have to wait more than 10 minutes is basically probability of that 0 less than X less than 5. This is because we are calculating X values after 7 onwards. Right? So 7 to 7.5 means that X value is between 0 to 5. And then this one is 15 less than X less than 20. Now again, if you do the calculation, it is therefore 0 to 5, 1 by 30 dx plus 15 to 20, 1 by 30 dx. 1 by 30 is outside into 5 minus 0 plus again 1 by 30 of 20 minus 15 is 5 again. So 1 by 6 plus 1 by 6 and this value is again 1 by 3. Right? So this is a very, very interesting example. I hope you understand and you enjoy it. Okay. Yeah, so this is the solution we have already done. We have one more example. Let the continuous random variable x denote the current measured in a thin copper wire in milliamperes. Assuming that the range of x is 0 to 20 milliampere and assume the probability density function of fx is equal to 0.05 between 0 to 20. Then what is the probability that a measurement of current is between 5 and 10 ampere? Now see, this one is uh, what is the density function of fx is given? So fx is basically given as 0.05. Now can't I write it that 0.05 is it not basically 1 by 20 minus 0? So 1 by 20 minus 0, right? 1 by 20 is actually 0.05. And which for which value? Whenever 0 less or equal to x less or equal to 20 and equal to 0 otherwise. What does it mean? It means x is a uniform random variable over the interval 0 to 20. Right? So according to the problem, we understood that x is actually an uniform random variable from the interval in the interval 0 to 20. Now next parts are very, very easy. The first part of this problem is what is the probability that a measurement of current is between 5 to 10 ampere? So the first part answer is uh, between 5 to 10 ampere. So probability of 5 less than x less than 10 and it is between 5 to 10 1 by 20 dx. And this value is 10 minus 5, so 5 by 20 and this value is 0.25. Here, then the next question is also find the mean and variance of the random variables. See, we could have calculate the mean and variance of this random variable, but we understood already that it is a uniform random variable over the interval 0 to 20. So we know its expected value and we know its variance, right? So expectation of this random variable is what? The uniform random variable expectation is alpha plus beta by 2. So here alpha is 0, beta is 20. So we know that the expectation is alpha plus beta by 2. That means the midpoint of the interval. It is 0 plus 20 by 2. That means it is 10. Similarly, the variance, we know the variance expression as well. It was beta minus alpha, right? It was beta minus alpha by 12. It was beta minus alpha whole square divided by 12, the variance calculation. So what is beta here? 20 minus 0 whole square divided by 12. And if you simplify it, you'll be getting this value as this value is 100 by 3. Clear? So we got the mean and variance. So sometime if you identify the random variable and if you know its standard formula, that what is the mean and variance, you can directly apply that. Right? I hope you understood these examples. So the content I have taken from these references. I hope you enjoyed the video. We'll meet in the next video. Thank you very much.